Hello everyone. In this tutorial I will be teaching stack data structure. So before implementing stack data structure, I will explain the theory behind it. So basically we have three operations in stack: push, pop and peek. So basically push means inserting an element into the stack. So a stack can be an array, linked list, anything. So basically push means inserting an element into the stack, and pop means removing the element from the stack. And the third operation is peek. So the peek is the topmost element. So here the 3 is at the top, so we just return the topmost element. We don't modify or edit the stack, we just return the topmost element. And there are two concepts which you have to keep in mind while creating a stack. So we will be keep tracking of a variable called top and capacity. So top records the number of items in the stack, and capacity tells the size of the stack. Like we can have only 5 elements, 10 elements. So we can determine the capacity of the stack while creating the stack itself. So for example, this is a stack. So consider this as an array. So if we had added two items into this array, 1 and 2, so the top will be 2. That is the number of items is equal to top. Here the number of items is 5, so top is equal to 5. And there are two concepts called overflow and underflow. If we exceed the capacity of the stack while inserting, for example, the capacity is equal to 5. This array can store only 5 elements, 5 items. If we try to store another element, we must return called overflow. So this is the reason why we record top and capacity. So if top is equal to capacity, while inserting, if we check top is equal to capacity, we'll return overflow as can't insert. And then there is another concept called underflow. For example, if there are no elements and the stack is empty, and if we try to remove, we must return a message called underflow. That is, there is no elements in the stack. So this is the theory behind stack. So let's start implementing stack. I'm using JavaScript to implement stack. So let's create a class called stack, and I'll use a constructor to initialize three values. First I'll be creating an array, an empty array, and we need two variables, top and capacity. So here I created top and capacity. So at the beginning there are 0 elements, so top will be equal to 0, and we can determine the capacity. It's user's wish, so I'll determine it can hold only 5 elements. I given just dot capacity is equal to 5. So let's create an object for this stack. So when you create this stack, these three values will be initialized to this stack object. So I'll console log this stack and I'll show you. So if I run, so we have an empty array, top is equal to 0 and capacity is equal to 5. If I initialize this array with 1 and 2, and if I run, so array has this array has 1 and 2 and top is 0. We have not added any push function here, so I'll do this next, and capacity is 5. So let's initialize back this to empty, and I'll run this. Now the first one is push function. So while pushing we need an element, so we pass it as an argument for this. So basically what we do while push is, so for example, top at the beginning top will be 0, so we have to give array of top is equal to that element. For example, if I have to insert an element 3 here, already the top value is 2, so array of top is equal to, if I give as 3, 3 will be stored here because the index value is 0, 1, 2, like that. So this dot array of this dot top is equal to element. So basically here top value is 0 here. So array of 0 is equal to whatever element we pass will be stored in will be pushed. And what I'll do is I'll increment the top after pushing. That's it. Push is done. So here we have to check a condition for overflow. If we exceed the capacity, for example, top should, if is equal to capacity, you must print it as overflow. That is, if the top is equal to 5 and the number of elements is 5, we have to print overflow and we must not insert inside the array. So I'll write an if condition. If top equal to capacity, I'll console log overflow. Else, I'll perform the push operation. And for our reference, I'll print the array 2. Now let's check whether push works or not. Write stack dot push. Let's insert 1. Sorry, this is if this dot top and this is this dot capacity. So we just don't write arr top and capacity as this is a class and each variable represents to this object. So we use this keyword. So if I run here, unexpected token, unexpected token. Let's run again. Yeah. So 1 is inserted, and if I put stack dot push, you copy this one. If I push 2, we have 1 and 2. We'll copy this for 4 times. 3, 4, and 5. So I'll clear the output. So if you execute, so while this line of code is executing, 1 is inserted, 2 is inserted, 3 is inserted, 4 is inserted, 5 is inserted. That is, it is inserted at the top. We can consider this side as the top and this side as the bottom. It is inserted. And if I try to insert 6, you must get overflow. This line of code must get executed. So clear the console. Only overflow is getting printed. Let's console log here or here too. Yeah. So overflow is printed and 6 is not getting inserted. Only the old array is returned. Now push is completed. Now let's execute pop, that is removing. We don't pass any element here, we just remove. So if we want to remove 2 from here, we must decrement top 2. We must just decrement the top. That's it. So let's decrement the top minus minus, and let's return that value like that. 5 is removed from the stack. Console.log this dot array of this dot top minus 1. Why minus 1 is here top is 2, but the index value of 2 is 0 and 1. So 2 minus 1, we get this top value. We put this inside string literal. So this value is removed from the stack. Then we have to even manually decrease the size length of the array. Then that's it. So if you execute this, and let's even console log the array after pop is performed. So I'll write here, I'll remove this one, stack.pop. So now we must get here 5 is removed and 1 2 3 4 as the resultant array. Yeah, 5 is removed from the stack and 1 2 3 4 is the resultant array. If I again perform stack.pop, 4 must get removed. Yeah, 4 is removed and this is the resultant array. And here we must have a condition. We have an edge case where if there are 0 elements in the stack, we must print a message called underflow and not execute anything. Or not execute this code. So let's perform underflow. If top is equal to 0, console.log underflow, else perform this code. That's it. So for example, I'll remove everything, and if I write stack.pop, we don't have anything in the array now. It must give key is not defined. What did I do? Sorry, this dot pop. This dot top. Yeah, underflow. As there is no element in the stack currently we got an error message called underflow. And next one is peak. Next operation is peak. So in peak we just return the topmost element. Here peak will be 2, here peak is 5. So to return peak we get top minus 1. So here 0, the index value of 5 will be 0 1 2 3 4. That is 5 minus 1. Top minus 1 will be the peak value. Peak console.log this dot top, this dot array of, and the index value, this dot top minus 1. This at the top of the is the topmost element. So let's have an edge case here too. If the stack is empty, you must write there are no elements. If top, this dot top, this dot top is equal to 0, console.log stack is empty, else we'll execute this code. That's it. So if I write stack.pick, as there are no elements, you must return stack is empty. Stack is empty, undefined is the I didn't write here else. Sorry guys. Stack is empty. So I'll insert some elements and I'll perform stack.pick. Stack.push 1, stack.push 2. So now stack.pick must return 2. Yeah, 2 is at the 2 is the topmost element. Yeah. So these are the different operations of stack, push, pop, peak, and we can even write the size of the stack. The size of the stack is nothing but top. We must just return this dot top. Uh, let's even do that. Size console.log this dot top is the size of the stack. So if I write here stack dot size, I must get 2 is the size of the stack, must be printed. What did I do? Hmm, yeah, sometimes compiler acts weird. 2 is the size of the stack. That's it. And we can even check if the stack is empty or not. If top is equal to 0, we can say stack is empty. We have already did this one. You can put this line of code inside a function called isEmpty, and this empty function is ready. So that's it, guys. I hope you guys understood stack data structure. um Thank you. In future I will do other data structures like queue, um, trees, graphs and all. Thank you for watching this tutorial. Bye.